All right, now let's get cracking with Module 2 for the AZ-305 exam. And in this section, we are going to be talking about design data storage solutions, which is 25 to 30% of this exam. So let's start with the first section of this section, design data storage solution for relational data. And one of the key items they talk about are data storage tiers. There's two vCore service tiers available both in Azure SQL Database and Azure SQL Managed Instance. There's general purpose, which is a budget-friendly tier designed for most workloads with common performance and availability requirements. And business critical tier is designed for performance-sensitive workloads with strict availability requirements. Azure SQL Database also provides a third one, the hyperscale service tier, which is designed for business workloads providing highly scalable storage, read scale out, fast scaling, and fast database restore capabilities. In preparing for this exam, it would be worth a look at the link at the bottom on the service tier comparison link. And again, I'll have these on my blog, which you see throughout the videos. The architectural model for the general purpose service tier is based on separation of compute and storage. This architectural model relies on high availability and reliability of Azure Blob Storage that transparently replicates the database files and guarantees no data loss if underlying infrastructure failure happens. In the architectural model for the general purpose service tier, there are two layers. A stateless compute layer that is running the SQL Server exe process and contains only transient and cache data. For example, a planned cache, buffer pool, and column store pool. This stateless node is operated by Azure Service Fabric that initializes, process, controls health of the node, and performs failover to another place if necessary. A stateful data layer with database files such as MDF and .ldf that are stored in Azure Blob Storage. Azure Blob Storage guarantees that there will be no data loss of any record that is placed in any database file. Azure Storage has built-in data availability redundancy that ensures that every record in log file or page in data file will be preserved even if the process crashes. When should you choose this tier? The general purpose service tier is a default service tier in Azure SQL Database and Azure SQL Managed Instance that is designed for most of the generic workloads. If you need a fully managed database engine with 4 nines or 99.99% SLA with storage latency between 5 and 10 milliseconds that match SQL Server on Azure virtual machines in most cases, then general purpose tier is the option for you. Business critical tier is called premium in the DTU purchasing model. Premium business critical service tier model is based on a cluster of database engine processes. This architectural model relies on a fact that there's always a quorum of available database engine nodes and has minimal performance impact on your workload even during maintenance activities. The hyperscale service tier is currently only available for Azure SQL Database, not SQL Managed Instance, and is a highly scalable storage and compute performance tier that leverages the Azure architecture to scale out the storage and compute resources for a database and Azure SQL Database substantially beyond the limits available for the general purpose and business critical service tiers. Compute and storage is integrated on the single node in the premium model. High availability in this architectural model is achieved by replication of compute and storage with locally attached SSC deployed to a 4-node cluster using technologies similar to SQL Server always-on availability groups. There are many reasons provided in this link as to when and why you should select this tier, so make sure you review those from my blog post. In summary, the business critical service tier is designed for applications that require low latency responses from the underlying SSD storage, such as a 1 to 2 millisecond in average, fast recovery if the underlying infrastructure fails, or need to offload reports, analytics, and read-only queries to the free of charge readable secondary replica of the primary database. The hyperscale service tier in Azure SQL Database is the newest service tier in the vCore based purchasing model. This service tier is a highly scalable storage and compute performance tier that leverages the Azure architecture to scale out the storage and compute resources for an Azure SQL database substantially beyond the limits available for the general purpose and business critical service tiers. The hyperscale service tier is intended for most business workloads as it provides great flexibility and high performance with independently scalable compute and storage resources. With the availability to auto-scale storage up to 100 terabyte, it's a great choice for customers who have large databases on premises and want to modernize their applications by moving to the cloud, that are already in the cloud and are limited by a maximum database size restriction of other service tiers, such as only 1 to 4 terabyte, or for customers who have smaller databases but require fast vertical and horizontal compute scaling, high performance, instant backup, and fast database restore. The hyperscale service tier supports a broad range of SQL Server workloads from pure OLTP to pure analytics, but it's primarily optimized for OLTP and hybrid transaction and analytical processing workloads. Scaling a database is as easy as using a slider in the Azure portal, believe it or not. Azure SQL Database offers the flexibility to dynamically scale your databases. With a single database, you can use either DTU or vCore models to define maximum amount of resources that will be assigned to each database. Elastic pools enable you to define maximum resource limit per group of databases in the pool. Azure SQL Managed Instance allows you to scale as well. SQL Managed Instances uses vCores mode and enables you to define maximum CPU cores and maximum storage allocated to your instance. All databases within the managed instance will share the resources allocated to the instance. In some cases, even the highest service tiers, compute sizes, and performance optimizations might not handle your workload in a successful and cost-effective way. In that case, you have these additional options to scale your database. Read Scale Out is an available feature where you're getting one read-only replica of your data where you can execute demanding read-only queries such as reports. A read-only replica will handle your read-only workload without affecting resource usage on your primary database. Database sharding is a set of techniques that enables you to split your data into several databases and then scale them independently. Azure SQL Database currently supports encryption at rest for Microsoft Managed Service-side and client-side encryption. Support for server encryption is currently provided through the SQL feature called Transparent Data Encryption, or TDE. Once an Azure SQL Database customer enables TDE, keys are automatically created and managed for them. Encryption at rest can be enabled at the database and server levels. As of June 2017, TDE is enabled by default on newly created databases. Azure SQL Database supports RSA 2048-bit customer managed keys in Azure Key Vault. Client-side encryption of Azure SQL Database is supported through Always Encrypted feature. Always Encrypted uses a key that is created and stored by the client. Customers can store the master key in a Windows Certificate Store, Azure Key Vault, or a local hardware security module. Using SQL Server Management Studio, SQL users choose what key they'd like to use to encrypt which column. All Azure storage services, Blob Storage, Queue Storage, Table Storage, and Azure Files, support server-side encryption at rest. Some services additionally support customer-managed keys and client-side encryption. For server-side, all Azure storage services enable server-side encryption by default using service-managed keys, which is transparent to the application. For client-side, Azure Blobs, Tables, and Queues support client-side encryption. When using client-side encryption, customers encrypt the data and upload the data as encrypted blobs. Key management is done by the customer. You can rely on Microsoft Managed Keys for the encryptions of your data. or you can manage encryption with your own keys. If you choose to manage encryption with your own keys, you have two additional options as shown in this graphic. You can use either type of key management or both. You can specify a customer managed key to use for encrypting and decrypting data in Blob Storage and in Azure files. Customer managed keys must be stored in Azure Key Vault or Azure Key Vault Managed Hardware Security Module HSM, which is in preview now. You can specify a customer provided key on Blob Storage operations. A client making a read or write request against Blob Storage can include an encryption key on the request for granular control over how blob data is encrypted and decrypted. Azure Data Factory is a platform that solves such data scenarios. It is the cloud-based ETL and data integration service that allows you to create data-driven workflows for orchestrating data movement and data transformation at scale. Using Azure Data Factory, you can create and schedule data-driven workflows called pipelines that can ingest data from disparate data stores. You can build complex ETL processes that transform the data visually with data flows or by using compute services such as Azure HD Insight Hadoop, Azure Databricks, and Azure SQL Database. The first step in building an information production system is to connect all the required sources of data and processing such as software as a service, databases, file shares, and FTP web services. The next step is to move the data as needed to a centralized location for subsequent processing. Without Data Factory, enterprises must build custom data movement components or write custom services to integrate these data sources and processing. It's expensive and hard to integrate and maintain such systems. In addition, they often lack the enterprise-grade scale monitoring, alerting, and controls that a fully managed service can offer. With Data Factory, you can use the copy activity in a data pipeline to move data from both on-premises and cloud source data stores to a centralization data store in the cloud for further analysis. For example, you can collect data in an Azure Data Lake storage and transform the data later by using Azure Data Lake Analytics compute service. You can also collect data in Azure Blob Storage and transform it later by using Azure HD Insight Hadoop cluster. You'll also want to make sure that you understand ADF's key components of pipelines, activities, data sets, link services, data flows, and integration runtimes. They are also on the detailed ADF architectural diagram you're looking at right now, so you might want to pause it for a minute and review. Azure Data Lake Storage Gen 1 is an enterprise-wide hyperscale repository for big data analytic workloads. Azure Data Lake enables you to capture data of any size, type, and ingestion speed in one single place for operational and exploratory analytics. You'll want to understand the key capabilities of Azure Data Lake Gen 1 versus Gen 2. Azure Data Lake Gen 1 is an Apache Hadoop file system that's compatible with Hadoop Distributed File System, or HDFS, and works with the Hadoop ecosystem. Your existing HD Insight applications or services that use the Web HDFS API can easily integrate with Data Lake Storage Gen 1. Data Lake Storage Gen 1 also exposes Web HDFS compatible REST interface for applications. Data Lake Storage Gen 1 provides unlimited storage and can store a variety of data for analytics. It doesn't impose any limits on account sizes, file sizes, or the amount of data that can be stored in a data lake. Individual files can range from kilobytes to petabytes in size. Data is stored durably by making multiple copies. There's no limit on the duration of time for which the data can be stored in the data lake. Data Lake Storage Gen 1 can store any data in its native format without requiring any prior transformations. Data Lake Storage Gen 1 does not require a schema to be defined before the data is loaded, leaving it up to the individual analytic framework to interpret the data and define a schema at the time of the analysis. The ability to store files of arbitrary sizes and formats makes it possible for Data Lake Storage Gen 1 to handle structured, semi-structured, and unstructured data. Data Lake Storage Gen 1 uses Azure Active Directory for authentication and access control lists to manage access to your data. Data Lake Storage Gen 2 converges the capabilities of Azure Data Lake Storage Gen 1 with Azure Blob Service. For example, Azure Data Lake Storage Gen 2 provides file system semantics, file level security, and scale. Because these capabilities are built on Blob Storage, you'll also get low-cost tiered storage with high availability disaster recovery capabilities. This also provides the foundation for building enterprise and data lakes on Azure. A fundamental part of Azure Data Lake Storage Gen 2 is the addition of a hierarchical namespace to Blob Storage. It is able to store and serve many exabytes of data. This amount of storage is available with throughput measured in gigabytes per second at high levels of input-output operations per second. These are the key features of Data Lake Storage Gen 2. It allows you to manage and access data just as you would with a Hadoop distributed file system or HDFS. The security model for Azure Data Lake 2 supports both ACLs and POSIX permissions, along with some extra granularity specific to Azure Data Lake Gen 2. Settings may be configured through Storage Explorer or through frameworks like Hive and Spark. Data Lake Gen 2 offers low-cost storage capacity and transactions. Features such as Azure Blob Storage Lifecycle optimize cost as data transitions through its lifecycle. The Azure Blob File System, or ABFS driver, is optimized specifically for big data analytics. A final note on this topic: Data Lake Storage Gen 2 supports the following authorization mechanisms to know: shared key authorization, shared access signature or SAS authorization, role-based access control, and access control list. I also discovered a best practices link, which I think is very helpful to review for this exam. So make sure you check that out when you get my blog list. Azure Databricks is a data analytics platform optimized for the Microsoft Azure Cloud Services platform. Azure Databricks offers 3 environments for developing data-intensive applications: Databricks SQL, Databricks Data Science and Engineering, and Databricks Machine Learning. Azure Databricks is structured to enable secure cross-functional team collaboration while keeping a significant amount of back-end services managed by Azure Databricks, so you can stay focused on your data science, data analytics, and data engineering tasks. This diagram you're looking at here shows the breakdown of the control plane where back-end services are managed by Databricks and the data plane, which is where the data resides and is processed. Azure Synapse is an enterprise analytics service that accelerates time to insight across data warehouses and big data systems. Azure Synapse brings together the best of SQL technologies used in enterprise data warehousing, Spark technologies used for big data, Data Explorer for log and time series analytics, pipelines for data integration, and ETL, ELT, and deep integration with other Azure services such as Power BI, Cosmos DB, and Azure ML. Azure Stream Analytics is a real-time analytics and complex event processing engine that is designed to analyze and process high volumes of fast streaming data from multiple sources simultaneously, as shown in the graphic. Patterns and relationships can be identified in information extracted from a number of input sources, including devices, sensors, click streams, social media feeds, and applications. These patterns can be used to trigger actions and initiate workflows, such as creating alerts, feeding information to a reporting tool, or storing transformed data for later use. Azure Data Lake Analytics is an on-demand analytics job service that simplifies big data. The one thing maybe worth noting is, as of December 2021, this is only available for Azure Data Lake Gen 1 and not yet for Gen 2. In this section, we want to review the options and consideration that as an Azure architect, you can recommend a data storage solution from all the options you see on this eye chart. We'll break these down categorically into these 3 types of data. 1, relational data. 2, semi-structured data. 3, non-relational data. Think of this diagram as your decision tree. The better you can somehow put this to memory, the better your chances at making recommendations on this exam based on the requirements you may be given in scenarios. The link at the bottom, Criteria for Data Store Choice, is another good read for your homework that breaks down both the functional and non-functional requirements to be considered. Within the umbrella of the Azure platform, there are many deployment options and choices that you need to make to meet your needs. Here are some of the considerations you need to make when you choose various Azure SQL deployment options as shown in the graphic, and also know these well. The deployment options to understand include SQL Server on virtual machines, Azure SQL Managed Instance, Azure SQL Database, Azure SQL Managed Instance Pools, and Azure SQL Database Elastic Database Pools. This is another good point to pause the video to take a good study and look at this graphic. Azure SQL Database has two purchasing models as shown in the graphic, DTU and vCore. DTU, or Database Transaction Unit, is a combined measure of compute, storage, and I/O resources. DTU model is a simple pre-configured purchase option. This is unavailable on SQL Managed Instance. When you need a bundled measure of compute, storage, and I/O resources, use the DTU model. vCore stands for Virtual Cores and lets you choose the number of vCores, which gives you greater control over the compute and storage resources that you create and pay for. The vCore-based model is recommended because it allows you to independently select compute and storage resources. The DTU-based model is a bundled measure of compute, storage, and I/O resources. The vCore model also allows you to use Azure Hybrid Benefit for SQL Server and/or reserved capacity, pay in advance to save money. Neither of these options is available in the DTU model. When you need the flexibility of selecting compute and storage resources independently, use the vCores model. Azure Database for MySQL is a relational database service in the Microsoft Cloud based on MySQL Community Edition database engine. Azure Database for MySQL, powered by the MySQL Community Edition, is available in two deployment modes, Flexible Server and Single Server. Azure Database for MySQL Flexible Server is a fully managed production-ready database designed for more granular control and flexibility over database management functions and configuration settings. The flexible server architecture allows users to opt for high availability within single availability zones and across multiple availability zones. The flexible server deployment option offers three compute tiers: burstable, general purpose, and memory optimized. Each tier offers different compute and memory capacity to support your database workloads. You can build your first app on a burstable tier for a few dollars a month, and then adjust the scale to meet the needs to your solution. Here's a key point to note. Single servers are best suited only for existing applications already leveraging a single server. For all new deployments or migrations, flexible server would be the recommended deployment option. Azure Cosmos DB is a fully managed NoSQL database for modern app development. Single-digit millisecond response times and automatic and instant scalability guarantee speeds at any scale. Here are the key benefits to note. You get unparalleled SLA back speed and throughput, fast global access, and instant elasticity. You can build fast with open source APIs, multiple SDKs, schemaless data, and no ETL analytics over operational data. You get guaranteed business continuity, 5 nines, 99.999% availability, and enterprise level security for every application. Any web, mobile gaming, and IoT application that needs to handle massive amounts of data, reads, and writes at a global scale with near real-time response for a variety of data will benefit from Cosmos DB's guaranteed high availability, high throughput, low latency, and tunable consistency. In Azure, non-relational data is contained in several different storage data objects. The storage account provides a unique namespace that's accessible from anywhere, assuming you have the correct permissions in the world over HTTPS. Data in your storage account is durable and highly available, secure, and massively scalable. When deciding how many storage accounts to have, this graphic shows the factors to consider. Again, you may want to pause the video to take a look at those. There are 4 data storage objects we'll focus on: Azure Blobs, Files, Tables, and Queues. And if you've been around taking some of these prior exams or studying for the 104, the 303, and 304, you should be pretty familiar with these, but we'll briefly cover these for you. If not, we have links for you to dive deeper. So Azure Blob Storage is an object store used for storing vast amounts of unstructured data, which includes objects such as images and multimedia files. Optimize blob storage costs by placing your data in the appropriate access tier. Make sure to know the differences between these tiers. As an example, we have premium blob storage, which is best suited for I/O intensive workloads that require low and consistent storage latency. Premium blob storage uses solid state drives for fast and consistent response times. This storage is best for workloads that perform many small transactions. An example would be a mapping app that requires frequent and fast updates. Hot access tier. By default, new storage accounts are created in the hot access tier. That's a good point to note for the exam. The hot tier is optimized for frequent reads and writes of objects in the storage account. The hot tier has higher storage costs than cool and archive tiers, but the lowest access costs. A good usage case is data that is actively being processed. The cool access tier. The cool access tier is optimized for storing large amounts of data that is infrequently accessed. This tier is intended for data that will remain in the cool tier for at least 30 days. The cool access tier has lower storage costs and higher access costs and compared to hot storage. A use case for the cool access tier is short-term backup and disaster recovery datasets and older media content. This content wouldn't be viewed frequently, but must be available immediately. And finally, we have the archive access tier. The archive access tier is optimized for data that can tolerate several hours of retrieval latency. Data must remain in the archive for at least 180 days or be subject to a more expensive than accessing data than in other tiers. Data for the archive tier includes secondary backups, original raw data, and legally required compliance information. Azure Files is a storage service that lets you access files via the SMB or Server Message Block Protocol, or CIFS, Common Internet File System, on Linux. You can also cache Azure Files shares on premises with Azure Files Sync. Azure Managed Disks are block-level storage volumes that are managed by Azure and used with Azure Virtual Machines, so you don't have to manage them. Managed disks are like physical disks in an on-premises server, but virtualized. Azure offers several types of data disks. When selecting a data type, consider your scenario, throughput, and IOPS. There are several encryption types available for your managed disks, but encryption types include Azure Disk Encryption, ADE, Server-Side Encryption, SSE, and encryption at host. Azure Queue Storage is a service for storing large numbers of messages. Queues are commonly used to create a backlog of work to process asynchronously. Azure provides built-in roles that grant permissions to call management operations. Azure Storage also provides built-in roles specifically for use with the Azure Storage Resource Provider. Built-in roles that grant permissions to call storage management operations include the roles described in the following table shown on the screen right now. This is one of those points, again, where you may want to pause the video to study this eye chart. I think the key call out are the 3 roles at the bottom, as they are built-in roles other than the traditional owner, contributor, or reader roles. A private endpoint is a special network interface for an Azure service in your virtual network. When you create a private endpoint for your storage account, It provides secure connectivity between clients on your VNet and your storage. The private endpoint is assigned an IP address from the IP address ranges in your VNet. The connection between the private endpoint and the storage service uses a secure private link. Private endpoints can be created in subnets that use service endpoints. Clients in a subnet can then connect to one storage account using a private endpoint while using service endpoints to access others. When you create a private endpoint for a storage service in your VNet, a consent request is sent for approval to the storage account owner. If the user requesting the creation of the private endpoint is also an owner of the storage account, this consent request is automatically approved. You can secure your storage account to only accept incoming connections from your VNet by configuring the storage firewall to deny access through its public endpoint by default. You don't need a firewall rule to allow the traffic from a VNet that has a private endpoint, since the storage firewall only controls access to the public endpoint. Private endpoints instead rely on the consent flow for granting subnets access to the storage accounts. Here's another video pausing moment for another eye chart. One particular call out here is to make sure that you know about shared access signatures if you didn't already and how they work. If you're not familiar with them, just go Bing it and you'll find what you need there. But each time you access your data in a storage account, your client application makes a request over HTTP or HTTPS to Azure Storage. By default, every resource in Azure Storage is secured, and every request to a secure resource must be authorized. Authorization ensures that the client application has the appropriate permissions to access data in your storage account. This table describes the options that Azure Storage offers for authorizing access to data that you should be familiar with for the exam. The link on Authorize, which will be on the blog, will further detail out these options if you aren't already familiar with them. If your application approaches or exceeds any of the scalability targets, it may encounter increased transaction levels or latencies or throttling. When Azure Storage throttles your application, the service begins to return 503 server busy or 500 operation timeout error codes. Avoiding these errors by staying within the limits of scalability targets is an important part of enhancing your application's performance. If you're approaching the maximum number of storage accounts permitted for a particular subscription/region combination, evaluate your scenario and determine whether any of the following conditions apply. Are you using a storage accounts to store unmanaged disks and adding those disks to your virtual machines? For this scenario, Microsoft simply recommends to use managed disk, which they happen by default, so you shouldn't have changed those. Are you using one storage account per customer for the purpose of data isolation? For this scenario, Microsoft recommends using a blob container for each customer instead of an entire storage account. Azure Storage now allows you to assign Azure roles on a per container basis within that blob. Are you using multiple storage accounts to shard to increase ingress, egress, I/O operations per second or capacity? In this scenario, Microsoft recommends that you take advantage of increased limits for storage accounts to reduce the number of storage accounts required for your workload if possible. Azure Blob Storage runs on Azure infrastructure that accrues costs when you deploy new resources. It's important to understand that there could be additional infrastructure costs that might accrue. Data storage and metadata are billed per gigabyte on a monthly basis. For data and metadata stored for less than a month, you can estimate the impact on your monthly bill by calculating the cost of each gigabyte per day. You can use a similar approach to estimating the cost of encryption scopes that are in use for less than a month. The number of days in any given month varies. Therefore, to obtain the best approximation of your costs in a given month, make sure to divide the monthly cost by the number of days that occur in that month. You can pay for Azure Blob Storage charges with your Azure prepayment, previously called monetary commitment credit. However, you can't use Azure prepayment credit to pay for charges for third-party products and services, including those from the Azure Marketplace. And once again, here's another good eye chart for you. Pause the video to review these data protection options. And just when you thought you were done with eye charts, shame on you. These are the basics that if you've been playing around with Azure certifications for a while, you should already know. But I do realize that some of you may just be learning Azure for the first time, or maybe you come from one of those other clouds. All good. This chart shows the key parameters for the various redundancy options available for Azure Storage. Azure Storage always stores multiple copies of your data, so it's protected from planned and unplanned events, including transient hardware failures, network or power outages, and massive natural disasters. Redundancy ensures that your storage account meets its availability and durability requirements even in the face of failures. When deciding, as an Azure architect, which redundancy option is best for your scenario, consider the trade-offs between lower cost and higher availability. The factors that help determine which redundancy options you should choose include how your data is replicated to the primary region, whether your data is replicated to a second region that is geographically distant to the primary region to protect against regional disasters, or whether your application requires read access to the replicated data in the secondary region if the primary region becomes unavailable for any reason. All right, that concludes Module 2. We'll see you on the next video.